Step-by-step process to install DeepSeek-VL2-Small MoE Vision model. Locally, for the purpose of this tutorial, we will use a GPU-powered virtual machine offered by NodeShift. However, you can replicate the same steps with any other cloud provider of your choice. NodeShift provides the most affordable virtual machines at a scale that meets GDPR, SOC 2, and ISO 27001 requirements. Step 1. Sign up and set up a NodeShift cloud account. Visit the NodeShift platform and create an account. Once you've signed up, log into your account. Follow the account setup process and provide the necessary details and information. Step 2. Create a GPU node virtual machine. GPU nodes are NodeShift's GPU virtual machines on-demand resources equipped with diverse GPUs ranging from H100s to A100s. These GPU-powered VMs provide enhanced environmental control, allowing configuration adjustments for GPUs, CPUs, RAM, and storage based on specific requirements. Navigate to the menu on the left side. Select the GPU nodes option, create a GPU node in the dashboard, click the Create GPU Node button, and create your first virtual machine deployment. Step 3. Select a model, region, and storage. In the GPU Nodes tab, select a GPU model and storage according to your needs and the geographical region where you want to launch your model. We will use one RTX A6000 GPU for this tutorial to achieve the fastest performance. However, you can choose a more affordable GPU with less VRAM if that better suits your requirements. Step 4. Select Authentication Method. There are two authentication methods available: password and SSH key. SSH keys are a more secure option. To create them, please refer to our official documentation. Step 5. Choose an image. Next, you will need to choose an image for your virtual machine. We will deploy DeepSeek-VL2-Small MoE Vision on an NVIDIA CUDA virtual machine. This proprietary, closed-source parallel computing platform will allow you to install DeepSeek-VL2-Small MoE Vision on your GPU node. After choosing the image, click the Create button, and your virtual machine will be deployed. Step 6. Virtual machine successfully deployed. You will get visual confirmation that your node is up and running. Step 7. Connect to GPUs using SSH NodeShift GPUs can be connected to and controlled through a terminal using the SSH key provided during GPU creation. Once your GPU node deployment is successfully created and has reached the running status, you can navigate to the page of your GPU deployment instance. Then, click the Connect button in the top right corner. Now, open your terminal and paste the proxy SSH IP or direct SSH IP. Next, if you want to check the GPU details, run the command below, NVIDIA SMI Step 8. Check the available Python version and install the new version. Run the following commands to check the available Python version. If you check the version of the Python, system has Python 3.8.1 available by default. To install a higher version of Python, you'll need to use the DeadSnakes PPA. Run the following commands to add the DeadSnakes PPA. sudo apt update, sudo apt install, y software properties, common sudo add apt repository, y ppa.deadsnakes ppa sudo apt update. Step 9. Install Python 3.11. Now, run the following command to install Python 3.11 or another desired version. sudo apt install y python 3.11, Python 3.11, distutils, Python 3.11, -venv step 10. Update the default Python 3 version now. Run the following command to link the new Python version as the default Python 3. Sudo update alternatives. Install usr bin python 3 Python 3. USR bin John to Python 3.8. 1. Sudo update alternatives. Install USR bin cht Python 3 USR to bin chihi Python 3.11 1. 2. Sudo update alternatives. Config Python 3. Then, run the following command to verify that the new Python version is active. Python 3 version. Step 11. Install and update. Pip run the following command to install and update the pip. Python 3-m ensure pip-upgrade. Python 3-m pip install -upgrade pip. Then, run the following command to check the version of pip. Pip --version, step 12, clone the repository. Run the following command to clone the DeepSeek-VL2 repository. Git clone https github.com/DeepSeek AI DeepSeek IL2 git cd DeepSeek-VL2. Step 13, set up environment. Run the following command to set up the environment. Python mvim DeepSeek han nv source DeepSeek nnv chart bin and activate. On Windows, DeepSeek -10 nv scripts. Activate step 14. Install dependencies. Run the following command to install the dependencies. Pip install step 15. Install Gradio. Run the following command to install the Gradio. Pip install Gradio equals 3.480 step 16. Check model and commands. The repository provides example commands to run the web demo using different model variants. Note that you should set the CUDA visible devices environment variable to the GPU you wish to use. In this example, GPU 2 is used, and specify the appropriate model name, port, and, if needed, the double-chunk size parameter. 1. For the VL2 tiny model details, total parameters, 3.37 billion MoE activated parameters, 1 billion suitable for a single GPU with less than 40 gigabytes. Memory command, CUDA visible devices, .h2, Python, web demo.py/h, model name, DeepSeek AI DeepSeek-VL2-Small, charge, port 379142. For the VL2 small model details, total parameters, 16.1 billion. MoE activated parameters, 380 million, 2.4 B memory. Note, when running on an A140 gigabyte GPU, you should set --chunk size 512 to save memory via incremental pre-filling at the expense of speed. On GPUs with more than 40 gigabytes, you can omit the double-chunk size 512 for a faster response. Command for a 40 gigabyte GPU. CUDA visible devices equals 2 Python web demo.py // model name DeepSeek AI DeepSeek-VL2-Small / port 37914 / chunk size 5123 CUDA visible devices equals 2 Python web demo.py / model name DeepSeek AI /DeepSeek-VL2 / port 37914. How to use these commands. Set the GPU. The CUDA visible devices equals 2 part tells the system to use GPU number 2. Adjust this value according to your system's GPU configuration. Run the demo script. The Python web demo.py command launches the Gradio-based web demo. Specify the model variant. Use the point model name parameter to choose between the different model variants. DeepSeek AI DeepSeek-VL2 Tiny, DeepSeek AI DeepSeek-VL2-Small, DeepSeek AI DeepSeek-VL2. Set the port. The report 37914 argument sets the port on which the web server will run. Open your browser and navigate to http://37914 to access the demo. Optional memory tuning. For the small model on a GPU with 40 gigabytes memory, the additional --chunk size 512 argument is recommended for memory-saving incremental pre-filling. Step 17. Verify your GPU availability. Run the following command in your terminal to see if your GPU is recognized by the system. NVIDIA SMI Step 18. Run DeepSeek-VL2 Tiny Model. Execute the following command to run the DeepSeek-VL2 Tiny Model. Python 3 audit web.demo.py. Model wide name DeepSeek AI DeepSeek-VL2 Tiny. Port 37914. Step 19. Access the application. Accessing the application at running on local URL http://0.0.0.0:37914. Running on public URL https 8 df6de5304350 ab2ecc.gradio